Hi, my name is Anne Makasinski, and today I'll be talking about my science fair project. So this year, I decided to invent a flashlight that runs solely from the power of the human hand. Here's my flashlight. So what I have here, these white tiles are the Peltier tiles. So what happens is I'm heating one side of the tiles with my hand, and the other side of the tiles are lying on this aluminum tube. Now, aluminum's a great heat sink, and it'll transfer the heat quickly. Well, take out the heat quickly, which is what we want. Of course, the best heat sink are diamonds. That would be a bit expensive, so I decided to use aluminum. The unique thing about the design of this flashlight is that because it's hollow, the air convection currents can flow through this whole tube and cool the other side of the Peltier tiles. So the greater the temperature differential between the ambient air and your hand, the brighter the flashlight will be and the more electricity produced. So I'm just going to show you a quick demo of how my flashlight works. Now, I'm in a science classroom right now and it is very warm in here. So most likely, because the temperature differential between my hand and this room isn't that great, this light I'm about to show you won't be at its full potential. This is flashlight, and right now it's lighting up. There's no batteries in it, no kinetic energy, it's just in the palm of my hand. And that's basically how my flashlight works. Thank you for listening. Hi, my name's Anne and I'm 15 years old. I live in Victoria, BC, Canada, and today I'll be talking about my hollow flashlight. So I became interested in the area of harvesting surplus energy when I realized that humans are a great source of untapped thermal energy. And my objective became to make a flashlight that runs solely on the heat of the human hand. I decided to use some cheap Peltier tiles. If this is the tile and you heat one side of the tile and you cool the other, electricity is produced. In my case, I'd be heating one side of the tile with the palm of my hand and cooling the other with just the ambient air. My first step was finding how much heat per centimeter squared our body radiates. I found this to be around 5 milliwatts, and I needed only 0.5 milliwatts to obtain a good, usable LED brightness. Step 2 was to do a small characterization test of the two different sized Peltier tiles. I found that both tiles produced sufficient energy, but only around a few millivolts. I needed around 2.5 volts. Step 3 was finding a way to boost my voltage. My final circuit had only 4 components. I obtained a good LED brightness with less than a 50 millivolt input and around 50% efficiency. My last step was designing the physical aspect of my flashlight. Because I only needed to heat one side of the Peltier tiles, the heart of my design was a hollow aluminum tube. The air flowed freely through the tube and also cooled the other side of the tiles. My results proved my hypothesis, and I was able to produce around 5 milliwatts of power and 5-foot candles of brightness. I achieved my objective of creating a flashlight that runs solely on the heat of the human hand. So here's my flashlight. I'll just give you a quick demo, and I'll put my hand on top of it and turn off the light. Thank you.